Hey, it's Abdul. Welcome to the final video on section 1 of the BIOSTATS CRUSH course. Today, we're going to be going over statistical tests. Now, I'm going to be real with y'all. This one's going to be a woozy. We have the basic core concepts, we have a bunch of questions to go through, and then we see how things tie into practice. So hang in tight, grab some popcorn, and let's dive right in. So last episode, we spoke a lot about hypothesis testing and trying to make sense of p-values. Now the monkey of questioning is back and he's like, Eto, how do we calculate the statistical significance between two groups? And that's a great question. And the way how we do that is through statistical tests. Now there's going to be a huge variety of different tests that you can use for different situations and different scenarios. And that's the beautiful, wild and wacky world of biostatistics. But for the sake of your exams, we're just going to focus on the ones that you need to know for the NBME, and the main three big boy culprits are going to be the t-test, ANOVA, and the chi-squared test. Now, in general, this is a very high yield topic, and that's why I decided to put a bit more love and a bit more attention to this video, because the NBME love to ask questions in terms of what test to choose for a specific scenario. The way how I would recommend that you approach NBME questions is by looking at those variables and following my three-step approach, which I'm going to go through a bit later on during this video. Now, as a gentle refresher, there are two kinds of variables that exist. You either have your independent variable, which is going to be the thingy that we control. It's the variable which is usually either the exposure or the intervention. And then you have the dependent variable, which is going to be the outcome. What changes based on the independent variable. Now, each variable could either be a quantitative variable or a qualitative variable, right? It could either be numbers, it could be on a scale, or it could be like a category, a class, gender, type of treatment, taking drug A versus drug B, or mortality. Did you die or did you not die? A yes or no questions. These are all going to be qualitative, and it's important because our decision to choose a statistical test is based on whether each variable is quantitative or qualitative. And the secret to really understanding statistical tests is through our trusty 2x2 table. On the left hand side, you can see we have the independent variables, the stuff that we control, and each independent variable could either be qualitative or quantitative, and then the dependent variable, which is either quantitative or qualitative. Now settle down, buckaroo, because right before we move on, I do have a disclaimer.
Stop it. Get some help.
It's very important to not jump and say something is quantitative if you see numbers. I've done that before. I've gotten a lot of questions wrong during my UWorld journey because I see numbers and I'm like, oh yeah, that's quantitative. The NBME can try to trick you. Make sure that you really read the variable and understand, because qualitative variables can still have numbers. They might give you the frequency of people who died, and that mortality is still a qualitative variables. So do keep that in the back of your minds. How do we choose a statistical test? Now, the most common combination that you're going to get is a qualitative independent variable with a quantitative dependent variable. Think of a treatment and the dependent variable is the cholesterol or the blood serum cholesterol given as a range, or maybe the uric acid levels in the blood. So this is an example of a qualitative variable and a quantitative dependent variable. For that, we have a bunch of options. We could use a t-test, we could use ANOVA, or we could use linear regression. NBME will never ask you to choose between linear regression and t-test. Right? This is way outside the scope of your biostatistics knowledge. What they might ask you is to choose between t-test and ANOVA, and instead of just telling you the answer right now, I'll tell you when to choose which when we go and solve some questions. Another potential kind of like pattern that you might get is that you have a qualitative independent variable and a qualitative dependent variable. Think of mortality data, think of total complications. You either got the complication or didn't. It's not within a spectrum. So in these scenarios, you will either use a chi-squared test or logistic regression. Again, they'll never ask you to choose between the two. You choose whichever one you will find in the answer choices. Now, this is a bit less common, but you might get a quantitative independent variable and a quantitative dependent variable. For this, you can either use correlation coefficients like R that we've mentioned in the previous video, or linear regression. And again, if they give you a quantitative independent variable and a qualitative dependent variable, you can just use logistic regression. Now, when can the independent variable be quantitative? Maybe in studies that look at exposure to something, right? Maybe exposure to cigarette smoke, and they give you a range, and it's in a unit where it's a quantitative unit. So these are a bit less common, but they do exist, so do keep that at the back of your heads. Ultimately though, the three most common are going to be the t-test, ANOVA, and chi-square test, and that's why most of our questions today will be revolved around those three. So how do I approach those NBME questions? This is my three-step approach. Step number 1, identify the independent and the dependent variables. Step number 2, really find out the true nature of each variable. Are they qualitative or are they quantitative? And then you got your trusty 2x2 table, bingo bango, get the answer right, move on, 3 marks, easy peasy. To see that in practice, let's go through some solved questions and try to see how to actually apply this 3-step approach to any NBME question on this topic. The first question here is about a local hospital. They wanted to do a study to look at the impact of supervision by attendings on baby residents. And they basically created 2 groups. One where the attendings were a bit more involved, they joined rounds, they kind of like watched the residents a bit more. And the other one where it was kind of more of a routine. The attendings didn't join rounds and they kind of just were there, right? Like what we normally expect from attendings. The residents were then randomly assigned to these 2 groups, and the big question was, the outcome was the total duration of patient rounds measured in minutes, and they're asking you what statistical tests should you use in very typical NBME fashion. 3-step process: identify the variables, find out whether they're qualitative or quantitative, and then bingo bango. So looking at this question stem, we know that the independent variable, the thingy that we are controlling, right, the groups, are going to be whether the attending is going to be increased supervision or normal supervision, right? So this is going to be the independent variable. And the dependent variable, right, the outcome is going to be patient duration, right? Sorry, duration of rounds per in minutes. So step 2 is think, right? So obviously the independent variable here is going to be qualitative, right? It's in categories, it's in groups. And the dependent variable is going to be quantitative. So we know that if we refer to our very trusty 2x2 table, we know that it's going to be either t-test, ANOVA, or linear regression. Then I look at my answer choice and I don't see linear regression. I do see t-test, but I also see ANOVA. So the monkey of questioning returns. So in my sense, how do we choose between t-test and ANOVA? And that's absolutely a great question. The answer is the number of groups. We use the t-test when we're comparing 2 groups, 2 means. And ANOVA is used when we're comparing 3 or more groups. In this scenario, there are only 2 groups, right? So increased supervision and normal supervision. So in this case, we would choose t-test. In a hypothetical scenario where there's 3 groups, less supervision, increased supervision, and normal supervision, that's when we're going to use ANOVA. All right. Keeping the ball rolling, let's move on to the second question. In this one, a study was conducted to determine the mean level of total serum cholesterol in patients with ACS. They took 1,500 randomly selected patients and compared their mean level of total serum cholesterol between male and female patients with ACS, and the results showed that the mean total cholesterol level was 220 milligrams per deciliter for males and 210 milligrams per deciliter for females. And the question that they want to ask you is what test should be used to determine if there is a difference between male and female patients. So again, 3-step process, super simple, super easy. Identify the variables. So in this case, the independent variable, the thingy that we're controlling, the 2 groups are going to be gender, and then the dependent variable is going to be the mean total cholesterol in milligrams per deciliter. We just go back to our 2x2 table and we know that we have a qualitative independent variable, a quantitative dependent variable. So we're either going to choose t-test, ANOVA, or linear regression. The answer choice does not have a linear regression, and it's only 2 groups, so the answer is going to be a t-test. Pretty damn simple. Final question, we have a study that was conducted to assess the association between hormone replacement therapy in postmenopausal women and the level of CRP, which is categorized as either high or normal based on predefined values. Now this is where I want you to take a step back. I know you see numbers, and I know there's an inclination to jump and choose quantitative for the CRP, but in this case, things are not what they seem. So step 1, identify the variables, right? So our independent variable is going to be hormone replacement therapy, and our dependent variable is going to be CRP. But the levels of CRP have been categorized as either high or normal. So in this case, the dependent variable is going to be qualitative, and the independent variable is also going to be qualitative because you either received it or you didn't. So in this case, we have qualitative independent variable, a qualitative dependent variable. So the best answer that we have is a chi-square test. If you don't see chi-square test in the answer choices, but you see logistic regression, you can go for that. And that wraps up the questions that we went through. I hope this 3-step process makes a bit more sense now, and hopefully this is going to be a great source of easy marks come exam day. Now, as we wrap up, let's explore how these statistical tests are used within research. And honestly, very simple. Whenever you look at the methods section of a paper, usually they'll have a section on the statistical analysis, and they'll mention which test they're using. So in this study, this RCT that looked at ultrasound guided femoral nerve block, you'll see that they said that for their descriptive statistics, we're going to use ANOVA for continuous variables and Fisher's exact test for categorical data. So immediately we know that they're probably dealing with more than 2 groups. Here's another study that looks at the use of endomethacin or radiation for heterotropic ossification, some ortho stuff here. And again, it's the same thing. You'll find in the method section, in the statistical analysis portion, what statistical test that they're going to use. So honestly, you'll see statistical tests everywhere you go, and it's a very integral part of the scientific process. So it's something that you will see throughout your research. And yeah, that's pretty much it. Thank you so much for listening, and also massive congratulations on being done with section 1 of the BIOSTATS CRUSH course. I hope that by the end of this you have a bit more of a stronger foundation on biostats that will help you come section 2 and especially section 3. Thank you so much for watching. If you've made it this far, I truly appreciate it. Do leave a like, comment, subscribe, hit the bell icon so you know when the next section will drop, and please leave any suggestions or comments or things that you want to see in future sections. Thank you so much for listening. If you are interested in having a mentoring session done, do let me know. We're going to be using code KLED, that is KLED, for 20% off. For the first 5, 10 people to use the code. Thank you so much for listening. Again, massive congrats to making it this far, and wishing you a beautiful, magical day.